Now, in this video, we are going to derive the formula for distance of a point from a line and distance of the origin from a line. Right. So here in the figure, you can see this is a line. Let's suppose its equation is in standard form, that is ax plus by plus c equals to 0. Right. And the perpendicular distance of this line from origin, let's suppose it is ON and the distance is, let's suppose it is P, right? So distance of origin from a line is given, we have considered it as P, that is the length of ON, right? We know that while finding the shortest distance, we are always taking perpendicular length, because there could be any length, right, from origin to the line. But as we want to find the distance, we are always taking the shortest distance, right? So remember this. Here I want to find the distance of origin from line, that is the length of ON, or we have considered it as P, right? And it will come to this. P equals to C upon root of A square plus B square, right? Let's start. Here you can see the line. Let's suppose I'll name it line L. Is intersecting x-axis, that is x-intercept is minus c by a, and the y-intercept is minus c by b. We have derived this, how to find the x-intercept and y-intercept. If you want, you can directly put y equals to 0. You will get x as minus c by a, that is x-intercept. If you put x equals to 0, you will get y as minus c by b, that is y-intercept, right? So in this way we have found x-intercept and y-intercept of the line, that is the point where the line is cutting x-axis and y-axis, okay? So here you can see there is a triangle ABC formed by the line after intersecting the x-axis and y-axis, okay? So here if I want to find this area of triangle ABO, that is triangle area of triangle ABO, right? By considering OA as base and OB as height. We know that perpendicular from one vertex to the opposite side will give you the height of the triangle, right? So here OB is my height, OA is my base. From the basics we can understand the length of OA is C by A. I am not taking minus C by A because length is always in positive. Similarly, the height OB will be this distance. What is that distance? It is C by B. Okay. The area of triangle OBA is half of base. What is the base? OA. What is the height? OB. Now, half of what is the length of OA? It is C by A. Into what is the length of OB? It is C by B. So what I will get? C into C, C square upon 2 into A into B. That is 2AB. Okay. So area of triangle OABO is C square upon twice AB. It will be equation, right? I can also find the area of this triangle by taking AB as base. How? I'll copy it and will show you. Here, if I tilt this, right, just have an idea, I have tilted. Here, you can observe, if I tilt the triangle like this, so the area of triangle ABO will be base. Area of triangle ABO is equals to half of, what is the base? Here I am considering base as AB into. Now we know the height, it should be perpendicular from the vertex, right? That is the length of altitude, right? So here this is perpendicular, right? So ON will be my height in this case. ON is my height. Just have to put the value of length of AB and length of ON. Here we have considered length of ON as P. I have to find length of AB, right? I will delete this. Let's find the length of AB. By Pythagoras Theorem in triangle ABO, I can find length of AB, that is hypotenuse. What is the area of Pythagoras Theorem? Hypotenuse square equals to squares of sum of squares of adjacent side. So square of OA, square of OB, right? And the length of OA is C by bracket square. Length of OB is C by B bracket square. It will be C square by A square plus C square by B square. Here if I take C square common, what I will get? 1 upon A square plus 1 upon B square. What I will get? I'll erase it. What I will get? AB square equals to C square, this B square into 1, B square plus this A square into 1, A square upon A square into B square, right? Now taking square root on both sides, what I will get? Length of AB as square root of C square, that is C. Square root of this whole numerator will be square root of B square plus A square. I can write it as A square plus B square, right? Square root of A square will be A. Square root of B square will be B. So here, in this way, I will erase this. In this way, I have found out the length of AB, right? Just put the length of AB. I am putting the length of AB in this formula. What I will get? C root of A square plus B square upon AB, right? This will be my equation 2. Just equation 1 and 2, because in equation 1 we have area of triangle AOB, and in equation 2 also we have area of triangle AOB, right? You can call it as AOB, ABO, anything, right? So I am erasing this also. I am doing it on the same page to have a proper understanding, right? In between, if you wish, you can take the screenshots so that you will understand. While practicing, you will understand the steps that we have performed, right? Okay. If I compare this, what I will get? C square upon twice AB equals to half of C root of A square plus B square upon AB into E. Here twice AB, this twice AB will be get cancelled. One C will get cancelled. What I will get? C equals to P into root of A square plus B square. If I take this root of A square plus B square to the left hand side, what I will get? C upon root of A square plus B square, which is the value of E, right? So this is my formula for the length of, or the perpendicular length of, from origin to this line. That is the distance of the origin from this line, right? We have found, or we have derived this formula, mod of C root of A square plus B square. Why I am taking here mod? Because P is the length and P cannot be negative. That's why we are always taking mod. Okay. So this will be your formula for distance of origin from the line. What here, if you see what we are doing, we are just taking the constant, dividing it by the square root of square of quotient of x and square of quotient of x dy sum. That is we are first finding the sum of squares of quotient of x and y, taking its square root and dividing c by this to get the distance of origin from line. Or I will also derive this formula easily by using the next topic, right? So if you are not understanding this, don't worry. In next topic you are getting, you will understand this, right? Okay. If you can remember, constant should be divided by root of square of x coordinate of x plus square of coordinate quotient of y. So not coordinate, it should be quotient, right? Okay. Let's derive the formula for distance of the point from a line. That means we will be given a point. Let's suppose the point P whose coordinates are x1 and y1. That will be given, and one line will be given. Let's suppose the equation of this line is ax plus by plus c, and they will ask you to find the distance of this point from the line. Now here you can observe PM is the perpendicular distance of this point P from the line. Let's suppose the length of PM is P, right? If I find this value of P, I will get the distance of the point P from the line. Okay, so let's derive how to find it. Here you can observe the line is intersecting x-axis at point C whose coordinates are minus c by a comma 0. That is the x-intercept. Right? Just put the value of y as 0, you will get this point. That is x-intercept. To find the y-intercept, just put the value of x as 0, you will get the y. That is the y-intercept. Here the length of OC will be my cy. Length of OB will be cyb, right? I can also find the length of BC by just applying the Pythagoras Theorem. So how to apply the Pythagoras Theorem? The length of BC will be the square root of sum of square of this and sum of and square of this. Here you can observe in BC is written as square root of sum of square of c by a and square of c by b, right? The length of BC is this, okay, by using Pythagoras Theorem. Okay. Now in triangle PBC, BC is my base, PM will be my height. So the area of triangle PBC will be half of base BC into height. I have just kept the value of BC and PM is the length. What we have considered length as P. So at the place of PM I am writing P. Okay. Remember this how to. And after solving this I will get this. Just cross multiply, take the square root, you will get this. So equation 1. In equation 1 we have found out area of triangle PBC. We can also find the area of triangle PBC by using the determinant method. We have seen this. I will just revise it. Let's suppose there is a triangle ABC. x1, y1 are the coordinates of triangle point A. x2, y2 are the coordinates of point B. x3, y3 are the coordinates of point C. How to find the area of triangle ABC if its coordinates are known? Vertices of its coordinates are known. Just take half of determinant. In the first column, write x quotient coordinates. Second column, write the y coordinates. It should be in order. That is x1, y1, x2, y2, x3, y3. Just put the values of the point, coordinates of the point. In third column, just put value 1. You can also write it as, this is the standard formula, but you can also write 1, 1, 1, x1, y1, x2, y2, x3, y3. Just I have took the transpose of it. You can write anything. Here in the book they have used it, so in derivation you will find this. You can also write this also. Okay. So this, just apply this formula in our figure also. That is here. Okay. So next page. Here, after applying the determinant formula for finding the area of triangle PBC, I will get half of same x1, y1. Quotient of second point will be here. First point is x1, y1. Second point is minus c by 0. Third point is 0, minus c by b. Here they have applied the same. Okay. After solving this, I will get this. Okay. Let's suppose it is equation 2. Now equate equation 1 and 2. That is the area of triangle PBC. Just solve this, half will be get cancelled. Just solve this. After taking C common, this C will be cancelled. In this C, taking C common, the C will be cancelled. I will get this. Just shift this to the right hand side. I will get this. And here the P is the length of perpendicular. That is the length distance of the point P from the line. So here in this way I have found the formula for the distance of the point from the line, which is ax1 plus by1 plus c upon root of a square plus b square. If you observe the formula, x1, y1 are the coordinates of point from which we have to find the distance of the line, right? So in short, what you have to remember, just remember, whenever you want to find the distance of a point from the line, just put that point into the equation of line. Here you can observe, I have just put your x coordinate at the place of x, y coordinate at the place of y. You will get this divided by the root of sum of square of x quotient of x and quotient of y. So just remember this formula. Let's take an example to understand this. Here they are asking you to find the distance of the point T2, 5 from this line. What I just said, just put the value into the, let's suppose this point is 2, 5 and this line is this. Okay. You want to find this perpendicular distance. Okay. What you have to do, let's suppose this is the distance. D will be, just put the value 3 into 2 plus 4 into 5 plus 14 upon root of square of x quotient plus square of y quotient. Okay. Why we are taking this mod? In the formula also we have the mod, because we are finding the length and length cannot be negative. That's why we are taking mod. 3 to the 6 plus 4 5 the 20 plus 14 upon square root. This will be my 9 plus 16, 25. Numerator, what I will get, 40 upon square root of 25, 5. 5 8 the 40. Right? Mod of 8 will be 8. So my distance is 8. So distance of point P 2, 5 from this line, 3x plus 4y plus 14 is 8. Here you can observe how easily we have found the distance. So just remember the formula. It is very important. This derivation is not that much important, but you should be able to find or derive the formula. Okay. Here also you can observe, if I want to find the previous formula, that was distance of origin from the line. If I apply this formula for finding the distance of origin from the line, what it will be? What I have to do, as I am finding the distance of origin, so this is this distance of origin. What I have to do, just put origin into the line. So it will be 0, it will be 0, it will get cancelled. What I will get, c upon root of a square plus b square, which will be my distance of origin from the line. So this was the same formula that we have derived. Okay. So by using the second formula also, you can derive the first formula, that is the distance of the origin from the line. Okay. Now let's derive the third formula, which is the distance between the two parallel lines. Here, let's suppose this is line 1. So the equation is ax plus by plus c1. Let's suppose this is line 2. So the equation is ax plus by plus c2 equals to 0. This is not y1, it is only y. Okay. Here you can observe, I have taken x coefficient and y coefficient as same, because these two lines are parallel, and always remember, when the two lines are parallel, their slope is equal. To make the slope equal, I have to take the quotient of x and y same. That is, this term will be same, just change will be in my constants. Okay. So whenever any equation is given, equation of line is given, if you want to find the general equation of the parallel line to this line, just take quotient of x term and y term same and take any arbitrary constants to represent the parallel. As the value of c changes, you will get lots of parallel lines to this. Okay. Just remember this concept that we have used here also. Okay. Now, let's suppose this line 1 is intersecting x-axis, that is making x-intercept as minus c1 by, we know how to find. Just put the y as 0, you will get x-intercept. So, it is minus c1 upon a. And let's suppose I am finding the distance between these two lines from point A. So, if I draw perpendicular from point A to line 2, let's suppose it is at point N, the perpendicular. This length of AN is denoted by P. So, P will be my distance between these two lines, L1 and L2, parallel lines. Okay. How to find the distance? I will use the previous formula, that is the distance of the point from the line. What was that? ax1 plus by1 plus c upon root of a square plus b square. Here x1 and y1 is the point from where you want to find the distance of the line. Here my x1, y1 will be this minus c1 by a and y1 will be my 0. And this equation I have to use. Right. So just put, so the value of p will be a. What is the value of x1? Minus c1 upon a plus b. What is the value of y1? It is 0 plus this is my c2 because I am taking line 2 upon root of quotient of x square, quotient of y square, quotient of y square, quotient of x square, and their sum and their square root. Okay. So this a cancelled minus c1 plus this will be my 0 plus c2 upon root of a square plus b square. You can write anything. That means c2 minus c1 you can write, or c1 minus c2 you can write. So here in my formula I got this root of a square plus b square, which is the formula for distance between two parallel lines. As this is mod, I can take this minus common. This will be the same. So just remember, whenever you want to find the distance between the two parallel lines, take the difference of your constant divided by same square root of sum of squares of x coefficient and y coefficient. Okay. To understand application of this, just take an example. Here, two lines are given. Okay. They are saying find the distance between these two parallels. You can observe these lines are parallel because if I take 2 common from this, what I will get? 3x plus 4y plus 7. Right. If this parallel was not there, I can observe these two lines are parallel and directly apply the distance between the two parallel lines formula. Okay, but here they are saying parallel, so we have to directly take the parallel. Okay. So what was the formula? Just take the difference between constant c1 minus c2 divided by square of x quotient, square of y coefficient. I will get 14 upon root of 36 plus 64. It will be 14 upon root of 100. What is the value of root of 100? It is 10. 2 5s are 2 7s are. So what I got? Distance as 7 by 5. So distance between these two parallel lines is 7 by 5. Okay. See you in the next part.